Yeah, lots of nods. Good, good, good. Yeah, my name's Dave Woloff. 35 years in the water industry, good grief. But that's what I did. That was my sentence. It's about 3 life sentences, I think. But last few years I've been an independent consultant and have had the privilege to work in Queensland and seen at first hand what the impacts of sustained drought, not a year's drought, but 6 consecutive years of drought, actually does to both the infrastructure of an area and the way that people live. So I'm really looking forward to hear what Richard's got to say on the subject this evening. I'm no expert, but I lived there for a little while and it was very, very interesting. So enough about me. I'd just like to introduce our speaker, which is Dr. Richard Allan, who's the bane of all chairmen's lives, because, of course, I have a biography and he changes his job a fortnight ago. So just to make life difficult, Richard was the chief, I've just altered that. Richard was the chief scientist for Scottish Water, but he's now MD of Scottish Water Horizons, which is their environmental and sustainability outfit, dealing with such things as hydroelectricity, etc. But Richard will tell you more about that when he comes up to the stand. Initially worked in the whisky industry before moving into the environmental sector in 1996. Joined East of Scotland Water in 1998 and held a number of senior management posts before becoming chief scientist in 2005. Richard sits on the Water Science Forum Committee and on the Standing Committee of Analysts. So without further ado, Richard, water sustainability, a global challenge. Thank you.
Thanks. Okay, thanks everybody for turning up in such a lovely evening, and just like to thank the Royal Society of Chemistry for inviting me here today to actually talk to you, find people about such an important subject as water sustainability. So, as you've just heard, I've actually changed my job. I was the chief scientist at Scottish Water, and I'm now looking after a company called Scottish Water Horizons. And Scottish Water Horizons has been created to basically exploit the resources we have in Scotland and look at better ways, more sustainable ways to produce electricity, recycle waste, look at anaerobic digestion for biogas formation. There's a whole range of really good things that we can do. So Scottish Water have kind of bundled all of those projects under one group and formed this company called Horizons. So I'm very, very privileged to have been asked to head that up. So I'm really excited about the opportunity. So before we go on to water sustainability, I think it's important that we just put this into some context. And as you can see from the words of Sir John Beddington, he's been very concerned about the challenge around a growing population. And the way he sees it is there's 3 key areas. There's water, energy and food. And this is a key theme that I'll keep coming back to throughout the whole of the presentation today. But the RSC itself is committed to looking at these challenges, and as a result of that, it produced a roadmap. And the roadmap came up with a range of priority areas, as you can see there, and hopefully you're all reasonably familiar with it. If not, you can go onto the RSC website and have a look at the roadmap and the roadmap documents. But anyway, today I'm going to specifically talk about the water sustainability challenge, and particularly looking at it from a UK point of view, but also from a global point of view. So I think the first thing to do is really just establish what we mean by water sustainability. I mean, there's different people have different views on what water sustainability actually means. But for the purposes of this lecture, I wanted to keep it as simple and straightforward as possible. So I've defined it as the continual supply of clean water for human use and other living things. So that should embody everything that humans need water for, but also points to the environment and the importance of maintaining the ecosystem. And I'll talk in a bit more detail about that as we go through. So a bit of good news to start with. Water is a renewable resource. I think that's a good thing. Unlike other resources that we use, it's certainly renewable, and I'll touch upon the water cycle. However, there's a few caveats with that. It is actually constrained by the natural processes that dominate globally. Water demand comes from a whole range of different sources and different views, and we need to take that into account. And infrastructure is limited across the world in developing countries and more developed countries. They all have different infrastructures, different robustness. And clearly human activity impacts on the quality and the quantity, so we need to bear all of these things in mind. So from my point of view, and I think everybody would agree with this, water equals life. It's very interesting to point out that really humans comprise of about 60% of water, give or take. So I mean, the bulk of us is made up of water. Therefore, it has to be important to us. It's needed for every sort of life, whether you're a single-cell organism or whether you're multi-celled. Water is a key ingredient. And water is needed to maintain the ecosystem and the environment well-being. Without water, we wouldn't have biodiversity, we wouldn't have good ecology, so it's absolutely critical for all the natural life cycles. And clearly water is used to produce food, energy and manufacture goods, amongst other things. So really there, within a few bullet points, you can see that water touches on everything that we do, and without it, we couldn't really make good progress. And clearly, water is required for safe sanitation as well. And again, when later in the lecture, I'll come on to the key point about the fact that we need to consider not just drinking water, but the whole of the water cycle. So, is water actually a limited resource? This is a good question. As you can see from the picture of the planet there, it looks like the surface area is practically covered with water, so there does seem to be an abundance of water on the surface of the Earth. And figures do vary from report to report, but by and large, we could say that, or estimate that there's about 1.4 billion cubic kilometres of water actually within the planet's surface itself. However, there's always a bit of a but. Approximately 35 million kilometres cubed is actually fresh water, and of that fresh water, a lot of it is actually captured in the Arctic and the Antarctic ice caps. So in reality, it's estimated that there's only about 100,000 cubic kilometres of fresh water actually readily available for human consumption and other uses. So when you put it in that context, in actual fact, water is a relatively limited resource, and we have to manage it wisely. So it's worthwhile just pausing and reminding ourselves of the water cycle and how fresh water is actually produced and the route that it actually takes to get to us for our consumption. So clearly there you've got the evaporation from the water storage in the sea. It basically condenses, forms rain, falls on the hills and the mountains and the land, and then it comes down into the rivers and it permeates the ground and into the aquifers, and then we can abstract it from the various different sources. But in order to be sustainable, we have to manage that full cycle. We can't just focus on one element of it. So if we think about the water cycle, what I've done here is I've thought about all of the different things that can have a negative impact on water sustainability, and I'm going to call these drivers for the purposes of this lecture. So there are a number of drivers that I think are important that we need to think about when we want to make water more sustainable. The first thing is population growth. Then we have climate change, which is a very topical issue. Land use clearly comes into it. Energy, as we'll see, energy, food and water are all very, very much interconnected. And global poverty, that's a critical thing in my view. So in terms of the rest of today's talk, I'm going to focus on this framework here, and I'm going to just talk in a little bit of detail about each of these different drivers before I go into where I think we can actually manage things more effectively and move to a more sustainable way of managing our water resources. So population, is this really a significant factor? Well, if we think back to the 1800s, it was estimated that the population of the world, in terms of human population, was around about 1 billion. So from the time that we started to evolve to the 1800s, it's taken that time to get up to about a billion population globally, give or take a few hundred people. But by 2010, and that's only 210 years from the 1 billion mark, we've suddenly hit close to 7 billion. I think, again, figures differ, but it's roughly 6.9 billion, but we're going to be at 7 billion fairly soon. And we're further projecting 9 billion in a few tens of years, really. So you can see there that there's an exponential population growth, and that has to have an impact on the water resources that we've got available to us. So in terms of those 7 billion people, well, realistically, we need around 2 litres of water per person per day to drink and survive and just meet the basic needs. But in terms of human activity in general, we need about 1,700 cubic metres per capita per year. That's just to take into account all of the other activities, whether it's manufacturing, social, cultural, all these kind of things. So in terms of the impact of population on water, well, clearly this is going to vary from country to country. It depends on whether you're an island or whether you're in a centre of a continent, depends whether you're near a river, depends on whether you're up in the mountains. So it does vary from country to country. However, what we're seeing is populations are migrating to coastal regions, and around 50% of the world's population is at the coastal regions now. And I'll show you this on a map in a couple of slides. Clearly, a higher population density in these areas are going to mean more stress on the water resources that are available in those areas. And it's very clear that water is not necessarily where the people are. So that poses another problem in terms of how do we actually make sure there's a continuity of supply there. And also, something I want to talk about in a bit more detail later on is importing virtual or embedded water. Now, as we become a more global world, and there's global markets and there's import and export of goods, we're also importing and exporting virtual water. We may be importing goods from countries that are actually running out or very close to running out of water and putting more stress on their water resources than perhaps we need. But there are other factors we need to think about as well. So it's like everything else, it's never very clear cut. But I think this is something that we need to think about sustainability. So here's the map I was referring to earlier on. And as you can see here, this is a kind of general population density of the world. And you can see the point I'm making where there's quite a lot of the coastal regions, particularly in South America, here, around the coast there, and North Africa. So you can see that there's quite a lot of population density. Okay, it's a little bit less. It's a little bit less like that in Europe. It's a little bit more spread out. And then you've got India here, and you've got China here, where you've got hugely populated areas, across quite large land masses, and Japan as well. So you can see I mean, clearly in these areas here, whether you've got very cold climates or you've got deserts, there's less population, which I guess is going to be fairly obvious. So if we contrast that to the water-stressed areas, there are some similarities, and you can see, if we flip back, you can see some areas where, if you take China and India, for example, you can see in India there we've got quite a lot of water stress. There's either a physical water scarcity or there's approaching a physical scarcity, yet you've got a huge population in that area. So clearly there's going to be issues there in terms of sustainability, and we need to think very hard about what needs to be done there. Okay, so I think you can see that there is a relationship between water and population, and that puts a great deal of stress on the global water resources that we have. So what about climate change? Does that impact on water resources? Personally, I think it does. Now, is climate change actually happening? That's always a question. Is it natural? Is it a naturally occurring warming cycle of the Earth? Is there human intervention? It's widely debated. You can see from most of the trends that are available that in actual fact in the last 100 years or so there has been an acceleration of temperature increase. So I think the data certainly suggests that something's happening, and that whether it's human or intervention or whether it's naturally occurring, there's clearly a warming of the Earth, so it's going to be a problem for us. And you can certainly see from a lot of the ice core information that we get that over the last few thousand years, it's been up and down a little bit, but then you get to more recent times and suddenly the CO2 levels increase. So there clearly is an issue. So in terms of the impact of climate change, I think there is enough evidence out there to suggest that climate change is real. I think that the IPCC and the fourth assessment, they reached a consensus that there was an impact of human intervention. So amongst the experts on climate change, they are actually saying that human activity does play a part in this. The thermal expansion of the oceans that's happening means that sea levels are rising, and I think that's a relatively well-known fact. So that will give rise to flooding, coastal flooding particularly, which is going to cause an issue when you've got 50% of the populations migrating towards the coast. And clearly snowmelt's contributing to a lot of this. And there's also less snow cover in some areas. So a good example of this would be Maine in America, where they're relying on a lot of snowmelt to recharge the rivers and the reservoirs in the springtime. And if there's less snowfall in the winter and there's less snowmelt coming off, then they've got less water resource available to them for the rest of the year. So even in areas as wet as Maine, they're seeing some problems in terms of the changes to the water resources that they have. And I think extreme weather events are more common. Clearly in the UK, you can see that over the last few years we've had periods of drought, we've had periods of flash flooding, we've had a very cold winter this year. It was certainly very snowy in Scotland, so we can expect more extreme weather events, I think. And I think a lot of people do question sometimes the whole climate change issue in terms of, well, why are we experiencing cold winter when the whole planet's supposed to be warming up? Well, I think a lot of it has to do with the thermohaline. And as climate change and as the temperature of the Earth heats up and you get ice melting and drifting down, you get ice drifting down from the Arctic, it competes with the Gulf Stream that warms up Britain and keeps it fairly temperate. And so you've got a bit of a battle here. So this is starting to cool down a little bit. It may not last forever. Once the snow is all melted, if it comes to that, then it may well be that temperatures start to increase quite substantially. But I think that we need to consider everything as a whole to fully understand the impact of climate change. So I think in terms of climate change, just to kind of sum up, I think drier areas will become drier. I think wetter areas will become wetter. We're seeing the evidence of that already. Flooding is going to clearly have an impact both socially and economically. We don't have to look too far in the past to see the impact that we've had in terms of flooding and drought in some parts of England particularly. Drought will have a similar impact, as I've just mentioned already, in England and the southeast particularly. We're starting to see a bit of water stress creeping in. The reservoirs aren't necessarily as full as they need to be, so there's a bit of concern there. And the mean, in terms of, we talk about global temperatures, the mean is perhaps less important than the extremes of variation. And again, it comes back to this, like, really cold spells or really hot spells. I think that we see extremes, and it's the extremes that we have to be concerned about, I think. But also we have to remember that there's a lot of uncertainty around the data that's being produced. And just by the nature of the kind of long-term changes that we see, it is very difficult to get certainty to plan for the future. And that means that adaptation planning becomes significantly more difficult. So we just have to bear these things in mind when we think about sustainable solutions. So, okay, just moving on to land use then. I think it's fair to say that as the human race, as people, we seek to create wealth and develop better ways of life. People want to do better. They want to secure the future. It's absolutely the right thing to do. So what that means is that over time immemorial, the human race has developed the land for agricultural purposes, manufacturing, municipal uses. I mean, there could be a whole range of other uses as well. but we are changing the landscape of the world, and this has to have an impact. So in terms of this slide, I think in terms of actually developing growth and developing like all the wealth that the human race and society wants, I think, as I mentioned earlier, the three key pillars, there's water, energy and food. And without these underpinning the whole of society, it becomes very, very difficult to move on progressively. So in terms of global food production, I want to touch upon this in terms of the demand for food and the impact on water. It's a very significant area. So if we look globally at food production, 69% of the water is actually abstracted for food production. I mean, this clearly varies from continent to continent. Europe, it's about 33%. Asia and Africa, it's anywhere between 85 and 90%, really. And if you compare this to other uses, so industry is about 23% globally, and domestics around 8% globally. So you can see that food and food production really does consume a lot of water. So in terms of, I touched upon the concept of virtual water and water footprinting a little bit earlier, and it's quite a good point to introduce it as we consider the impact of food production globally. So the concept of virtual water or embedded water was first put forward by Professor Allan in 1993. And clearly, environmental footprinting had been developed from about 96, and it's fairly a well-trailed idea. But these were combined by Professor Hoekstra in the Netherlands, and he could come up with the concept of water footprinting. So just to give you an understanding of what that means and give you some definitions, water footprinting is the total volume of fresh water that's used to produce goods and services. And it's summed over the full supply chain from the point at which you actually produce the goods to the point at which you deliver it and consume it. And it's expressed as a volume of water there. Per individual, it's per litre per person, really, business, nation, etc. And then per output, it's litres cubed per kilogram. And it can be applied to a product, process, or an organisation. It can be applied to practically anything that uses water. And it's a measure of the appropriation of water, so how much water is actually needed to actually produce that particular good or service. But it's not a quantitative measure of impact, and I'll say a little bit about that in a moment or two. So just to give you an idea of what I mean about embedded water, here's some facts and figures that have been developed by these researchers. And you can see there that tomatoes grown in Spain basically consume about 74 litres per kilogram. So if you were to buy a kilogram of tomatoes from Spain, you would also be consuming 74 litres of water per kilogram, which is quite significant. But if we run down that list, you can see certainly at the end here, in terms of meat production, you're talking about close to 18,000 litres per kilogram of beef. So that's an awful lot of water that you're actually consuming over and above what you would normally consume in terms of meat production. Okay, but it's not as clear cut as just taking the volume of water, because 18,000 litres sounds quite a lot of water. You have to take account of the colour of water as well. And so what do I mean about that? Well, there are three key categories. There's green water, blue water, and grey water. Green water, that's just the water that falls at the point of use, so basically rain or snow. But it's basically going to fall and be consumed regardless of whether you're producing some goods or not. It's just inherently there in the environment. And then we have blue water, which is probably the more significant one, because that's the water that we physically abstract to actually produce the good or provide the service. And then we have grey water, which is really perhaps slightly tainted water, but basically it's water that can be reused and used to dilute other polluted return flows, as it says there. So grey water can be used a lot in production of food. You know, like cooling water is a good example where you can recirculate water that's been partially used before. So as I say, colour I think is actually quite important. Here's a couple of well-known brands. Now you can see there that producing something like M&M's actually takes about 1,153 litres compared to some pasta sauce which takes about 202 litres. But in reality, the blue water content is about the same. It's about 127, 128 litres. So, okay, that's not too bad. Then you look at the green water, and that's where the major contribution is in the peanuts. But you would expect that, because peanuts have to be grown in areas where there's a lot of rainfall, and they need to be grown in fields and so on. And the grey water is roughly the same. So in order to understand the impact of the embedded water, you have to break it down a little bit further and understand the contribution of each of these three areas. So just to give us an idea about the impact of this, what does this actually mean? I mean, it all sounds quite academic, but in actual fact, it has quite a big impact in terms of global economics. And I am just touching on this subject. It's a fairly deep and detailed subject. But here you can see in places like North America, Brazil, and Australia, there's a net export of water. Now, in America, in some parts, they've got a reasonable amount of rainfall, so that's perhaps not so problematic. But in somewhere like Australia, we've touched upon the fact that it's already water stressed. So we're actually removing quite a lot of water from Australia and moving it about to other parts of the world. And you can see that the Middle East and Central and Southern Asia and in Europe, we're actually net importers. So there's a number of consequences for that. It means that if we decided to grow all of our food locally, we may run into problems in terms of having enough resource to actually sustain the food output that we need to sustain the population. But equally, we have to be mindful of the fact that some of these countries, like Africa, are developing, so you wouldn't necessarily want to move all food production to Europe and damage the growing economies in these developing countries. So there's always a balance. But you can certainly see that we are over-reliant in Europe on exporting goods and exporting water towards us. So that could be a problem for food security in the future, I think. So food waste equals water waste. Again, because we've got a lot of embedded water in food, we have to think about the amount of water we're actually wasting while we're throwing out food. And in the UK, on average, we're actually throwing out about 30% of the food, which to my mind seems a lot of food. Again, I'm sure figures vary from report to report, but on average it's about 30%. And that really means that the avoidable waste represents about 243 litres per person per day of water that we're wasting through that actual activity. Now, to put that into context, you would, on average in the UK, use something in the lines of 150 litres of water per day per person. So over and above that 150 litres, you're talking about using another 243 litres of embedded water and just throwing it away as rubbish. So I think what is the impact of this water? I think the impact's quite significant. It's significant for the developing countries that we're actually removing the water from, and it's significant for us in terms of the amount of waste that we're producing. So points to note, water footprints are important, but it's the impact that's important, and as I say, we have to think about the colour. It's not all about the size, as I've demonstrated there. You may have quite a large water footprint, but you do need to understand the amount that's actually used in terms of abstracted water versus green water and grey water. It's not just about consumers, it's about the whole supply chain, and water is critical to the whole supply chain. And I think the key point here is that water footprints are a very good idea because they encourage this kind of debate about wasted water and the strain on resources at a global level. Okay, so moving very quickly on to energy. Again, just reminding ourselves of this energy, water, food relationship. It's a key pillar in terms of supporting society in general. Clearly, there's a lot of energy choices: biomass, biofuels. These are becoming a bit more common. Oil, nuclear, coal, and then you've got a range of renewable ones like hydro, wind, solar, and tidal. And I'm sure you could come up with another 2 or 3 examples as well. So what about biofuels, oil, nuclear and coal? Well, they all do impact on water resources significantly to a greater or lesser extent, both in terms of quality and quantity. And biofuels they have become more of a hot topic, But the reality of it is that the biofuels, if you grow them in quantity, they remove food from the food chain. That's a key thing. But also it can cause nutrients to run off the land. Eutrophication is a risk, clearly. And even if they were to replace fossil fuels with biofuels, I don't think they would be able to grow enough to replace fossil fuels completely. So that could be an issue. So in terms of how does water relate to energy, well, you can clearly see it relates in many ways. You need water to cool the power plants. You need water for the dams. You need water to help mine the fuels and so on. You need energy to pump water to cities and towns. You need energy to remove waste and treat waste and so on. So it's all integrated and it's all interconnected. So I think energy needs to be thought about quite significantly when we think about water sustainability issues. Okay, so in terms of poverty, I mean, I think social justice is a key thing for everybody to be concerned about, but what do we mean by social justice? Well, personally, I think everybody in the world has the right to clean, fresh drinking water, and I don't think anybody would disagree with that. I think it's absolutely right that people should have clean, safe drinking water, because as I said at the beginning, that's a key factor for life. And linked to that, safe sanitation is an absolute underpinning thing. It's fine having drinking water, but if you can't remove waste safely, then you get all sorts of diseases and deaths caused by diseases. Food security is absolutely critical here. Economic growth underpins all of this. You need a good, sustained environment to support this, and clearly that should lead to some sort of sustainability. So in terms of the Millennium Development Goals, I just want to mention this here. Back in 2000, 189 countries met in New York, and the discussions were around how they could actually reduce human suffering. And as a result of that conference, there was about 8 actions identified that could actually alleviate human suffering. All the countries involved were signed up to it, and they had a target date of 2015 to meet the objectives of the Millennium Development Goals. And I mean, if we think about that, that's only 3 or 4 years away. So how are we doing? Well, I think things like linked to growth, AIDS, women's rights and education, they all seem to be progressing reasonably well. It varies from country to country, but I think you can see that there is some good activity there. But some of the goals that were agreed that are linked to water, sustainability and health, they've not really made such good progress in some areas. So these are areas that we need to continue to push for. So in terms of poverty, again, it's a very personal thing to me, but I really don't think we can tackle climate change, environment or development without first reducing or removing poverty. I mean, with anybody, I think there's a famous psychologist, Maslow, who came up with a hierarchy of needs, and that's his theory says that unless you have security, and by security that means a good place to live, you've got money to spend on things like food and water, then you can't really put your mind to doing anything else. So I think it's absolutely critical that we get poverty resolved quite quickly. And I think it's an important fact to recognise that there are still around 1 billion people living on less than £1 per day. I mean, that's an astonishing fact. That's like 1/7 of the population of the world. And for me, that's far too many. And again, there are over 900 million people who do not have access to safe drinking water globally at the moment. Again, it's just, I find that fascinating fact that there are still that many people that don't have access to safe drinking water. And equally, there are about 2 billion people who do not actually have access to safe sanitation, which, as I say, in terms of sustainability, you have to think of the whole water cycle. So that's equally important as drinking water. And as a consequence, the number of children below the age of 5 are still dying through preventable diseases, which again is just, in my view, unacceptable. And that's a key thing that people need to think about. So those are the drivers for water sustainability. So in the next kind of section of the presentation, I want to just talk about, well, how we're actually going to adapt and how we're going to make things a bit more sustainable and move things forward in a positive way. Well, I think we need to consider the ecosystem services approach, and I'll go into that in a little bit more detail. We need to develop and maintain infrastructure, absolutely critical. We need to mitigate some of the drivers, and we need to adapt to the changing water demands, some of which I've touched upon in the first part of the presentation. And we certainly need to make better choices about the water resources that we're using. Clearly, we need to improve our monitoring, modelling and forecasting capabilities, and we need to look at more sustainable ways of manufacturing and agricultural stuff. So in terms of ecosystem services, again, round about the Millennium ecosystem assessment was set up, and it was looking at sustainable environmental solutions, and it came up with a number of things. But the key output really was that it classified services into 4 principal groups. So there was provisioning services, regulating services, supporting services, and cultural services. And what the idea is that if we focus on these 4 areas, then we should be able to make environmental management a bit more sustainable. So there's a little diagram for you. In terms of provisioning services, what I'm talking about there is the production of food, fuels, fibres, chemicals, waters, and new technology and computers and a whole range of other things. And then in terms of regulation, well, these have to be regulated. So again, that's about regulating the manufacturing and production services. The supporting service is very critical. That's about looking after primary production, looking after the provision of habitats, the nutrient cycle, production of natural oxygen, soil formation and retention. So that's about some physical management of the environment. Equally important in terms of environmental and ecosystem sustainability is taking into account things like the spiritual and religious beliefs and values of the people, the knowledge base that we've built up, education and inspiration, recreation and aesthetic qualities and values. So I think as well as developing good growth models, we need to have a place to relax and enjoy the environment and so on. And if we get all of that right, then it should actually lead to a more sustainable environment. And of course, if we have a more sustainable environment, we'll have a more sustainable water resource sit behind that. And water resources are interlinked with making sure that the environment is sustainable as well. So in terms of water cycle engineering, again, thinking of it holistically, well, we tend to focus on drinking water, but as I've said throughout this presentation, sanitation is equally important, and we need to think of it holistically. We need to consider the impact of waste on environmental sustainability, and we need to consider the whole water cycle rather than just small parts of it in isolation. So here's a nice little diagram which shows kind of in this half here, this is kind of how a lot of people do things at the moment, which is really unsustainable. So you've got a lot of waste discharge into the watercourse, you've got over-abstraction of the aquifers, you've got the potential for contamination to get drawn into the aquifer there, which would mean that the aquifer is no longer able to be used. You have unsustainable agricultural practices there. So generally, we need to change the way we manage these things. So in terms of on the sustainable side, what I think is important here is that there's a lot more recycling and reuse of grey water, and we're trying to maintain a closed system here without affecting the watercourse itself. And we need to move towards a zero wastewater discharge into our rivers and our reservoirs. There needs to be a more sustainable approach to agriculture. And the aquifers that we use for abstraction need to be protected. We need to ensure that there's no ingress of contamination. So in terms of just kind of blowing up the city element of this a little bit and going into a bit more detail, in terms of sustainability, what do we need? Well, building design needs to be changed going forward, I think. If there is a risk of flooding, then we need some sort of flood mitigation measures there. There needs to be better design of recreational grounds so that there's a bit more flood management as well. There needs to be better drainage systems. There needs to be better mechanisms for recycling waste throughout the city. So all of these things get factored in. But equally, in terms of futures, in terms of sustainable farming, that's equally important. There needs to be an improvement in things like catchment management. You need to manage livestock so that they're not polluting rivers and watercourses. Within the farming, there needs to be better capture of rainwater and better use of that type of thing. Better use of recycling grey water on the farms. So what about desalination in terms of water sustainability? Again, touching on one of the first slides and thinking about the amount of water that's actually held globally, surely desalination is a good idea. There's plenty of water out there if we can just extract it. Well, I think probably it is a good idea, but at the moment it's very, very energy intensive. So if we started to produce desalination plants on a massive scale, you're going to need a huge amount of energy, which could actually tip the balance in terms of climate change if it's not managed properly. So in terms of the power output required, it is quite high at the moment. And also, desalination produces a large amount of brine, amongst other things. It produces a number of other undesirable byproducts as well, so that needs to be addressed. But, I mean, it could be a solution in the future. I mean, I'm sure with advances in innovation and technology, desalination may become cheaper, more energy efficient, more efficient in general. We may find uses for the byproducts and so on. So it shouldn't be discounted. But just to give you a kind of real example, I think it's worthwhile having a look at Singapore and what they did in terms of water sustainability. Singapore is a city-state of around about 4.6 million people, and they recovered most of the water that fell in the area that they were in control of. But even with that, they actually still had to import a lot of water from Malaysia. So they clearly identified that water sustainability and water security was an issue, and there was a need for investment. So about 20 years ago, give or take, they put a plan together to actually invest heavily in the water infrastructure. Now, at the time, they actually did plan to build desalination plants. However, when they thought about it in a bit more detail, they actually discovered it was cheaper to reuse the wastewater from domestic and industrial. So they came up with some really nice novel solutions, and they decided to use microfiltration, reverse osmosis, UV disinfection, and that's been a great success for them. And Singapore are very much held up as leaders in water sustainability and water management. So I think that's a good positive example for this lecture. So in terms of water infrastructure, again, clearly I've said that infrastructure is critical, and in most developed countries there are reasonably robust infrastructures. There needs to be a bit more investment in maintaining them on an ongoing basis. But what about poorer countries? There's lots of countries out there that they've got more pressing priorities than actually building civil projects and infrastructure. It comes back to the poverty question. And also, what about countries that are in conflict, or they have unstable governments, or there's unclear in terms of direction? What do these countries do in order to secure supply of water? This is going to be very tricky. And again, clearly their priority for investment is going to be different from more developed countries. So as well as robust high technology solutions, I think we also need low-tech solutions, and I can't emphasise this enough. Quite often people are really excited by the very, very special high-tech, very expensive technologies, but I think for a lot of countries in the world, that's just not really a sustainable solution. So we need to provide and think of low-cost, low technology, low maintenance solutions for these situations. And I have to say, in Scotland, we actually look at low-tech, low-maintenance solutions in rural areas. So the same kind of principles can be applied in many, many different countries for many, many reasons. But you know, the point I'm making is that it has to be a combination of good innovation, but also cheap, robust, low-maintenance solutions. And also, what about using grey water? I think in terms of if we're serious about sustainability, I think the use of grey water particularly in this country, is going to become more integrated. I think if you think about the UK as a whole, Scotland actually holds roughly 90% of the UK water resource, and our population is about 5 million compared to the rest of the UK. So, which is about 70 million roughly. So 5 million people are sitting with about 90% of the resources. Clearly, with the 10% resources that are left and the bulk of the population, we're going to have to think of new and clever ways of reusing our own water. And I think going back to the point I made earlier about the fact that most people use about 150 litres of water per person per day. The majority of that gets used in flushing toilets, showers, washing, and so on. You don't really consume that much in terms of actually drinking it out of the tap, and quite a lot of people are buying bottled water anyway. So a lot of the water that's used and disposed of and then goes into the wastewater cycle could be reused more effectively. So here we've got a little example where you can actually draw the water away and perhaps put it into a holding tank or a reuse tank and use it for other things like watering the lawn or irrigation. I mean, there's a whole range of things that we can use it for. So I think that's something that needs to be considered. I haven't got rainwater harvesting up here, but rainwater harvesting is another thing that we should be thinking about in terms of capturing water for other specific uses. Needs to be thought about. Okay, so in terms of what should we focus more on, or what should I think we focus more on? Well, I think clearly if we're going to be sustainable, we need to influence the policy. Policy and legislation is going to drive behaviours. If the regulations state we do something, generally we do it. So we need to ensure that the regulations that are produced are appropriate and that they drive the right behaviours towards a sustainable practice. And there clearly needs to be an investment in education. Again, that underpins the whole thing. We need to spread a lot more knowledge around these subjects. Make sure people understand the consequences of inaction as well as action. We need to support the developing nations. We need to make sure that, as I say, we eradicate poverty and we support developing nations with new and novel technologies, cheap solutions, low maintenance solutions. We need to apply the ecosystem services approach. I can't emphasise enough the fact that we need to look at the whole thing holistically. If we support the environment and we support the water cycle, then things become easier to maintain and become more sustainable. Supporting innovation, well, we're not going to do this without coming up with some new and novel ideas, and we need to find some good solutions to some of these problems. We need to not forget about the Millennium goals, and we need to continue to support these goals and make sure that they're followed through. And again, we need to reduce and eradicate poverty, because unless we do that, people aren't going to be engaged with the wider debate about climate change, environment, and virtual water and these kind of concepts. So in summary, there's what I think some of the key drivers are. We've talked around population, climate change, land use, energy and poverty. And in terms of mitigation and adaptation, I think clearly there's investment in infrastructure, investing in innovation, addressing the poverty, some of the low-tech solutions we need to remember about, and investing in education. So in conclusion, sustainability is actually quite difficult to maintain, but we do need to consider the whole water cycle. Continuous improvement is actually achievable, which is a good news story. I think with a bit of effort and a bit of focus, it's actually quite easy to do. Poverty needs to be addressed to resolve this. And a key point I mentioned before, food, water and energy, they're all interconnected. So if we're trying to address one problem, we may create a problem elsewhere. So we just need to be mindful of the choices that we make around all three of these activities. So anyway, just to finish off this lecture, I just want to touch upon the role of the RSC in all of this. Well, the RSC, through the roadmap activities, has a clear line of sight between the chemical societies and supporting some of these water sustainability issues. And the RSC recognise this in the roadmaps and the reports that's done on water, whether it's the Water Sustainability Report or whether it's the Water for Africa report. And the RSC is working with associate organisations to promote action, positive action. And we do this by underpinning it in terms of supporting education, research and development, which is absolutely key to the success of it all. So in terms of underpinning science, the RSC recognise it includes things like analytical, catalysis, chemical biology, computational chemistry, materials, etc., etc. In terms of making it happen, well, we need to make it happen by supporting the stars of the future and supporting education and supporting these guys to actually get them involved and excited about these issues that are of a global priority. We need to create an innovative climate. So the RSC will build upon this by developing new projects and tackling some of the key challenges. In terms of working together, Collaboration is a central theme of the RSC, and the RSC will integrate its priorities with strategic partners as outlined there, so governments, funding bodies, learned societies, etc. Very important. So I'll wrap up now, but if you want to get more information on the RSC and the roadmap, or you want to get involved in a bit more, then you can find out more or contact the RSC in these websites and at this email address. And with that, thanks for listening.
Right, very thought-provoking, and particularly thank you to Richard for moving on at a pace, because we are a little constrained for time this evening. I found that very interesting. As I said, I have a little experience of water conservation. So it's time to move on to questions. We have a bit of a plan for handling the questions, if we could. If you'd make yourself known to me, sort of wave, jump up and down or something or other, and then we'll get a microphone to you. If you could avoid speaking before the microphone gets there, I know it's all very exciting, but if we can hang on, because otherwise we can't hear you. If you could let us know who you are and what, if any, affiliation you have before asking the question, I'll then duck and pass over to Richard. So, first question. Gentleman from the back there.
Thank you. David Summers, a member of the Royal Society of Chemistry. Two questions, actually, quite different. One, fracking is very much in the news at the moment. What's your view on the debate about fracking and the impact on water? And no doubt you'll explain to people what fracking is in case they don't know. And the second question I have is, you talked very much about the importance of water and needing to do something in the poor countries and so on. What, in practical terms, would you suggest is done in places like, for example, Haiti?
Okay. Well, I would actually appreciate if you could give me an explanation of fracking, haven't it?
Okay. Fracking is where people are drilling into the certain rock structures and would think explosives and then drive in sand and water and chemicals to drive out gas, and it's called shale gas. And for example, in America, the United States now, they've got these huge quantities of shale gas, which will keep them going for the next couple of 100 years. But it's been banned now in Pennsylvania, New York, and one or two other parts of the U.S. You had in the Blackpool area reports of perhaps 2 earthquakes caused through fracking in the last few days. But it's a growing phenomenon, this technique of releasing gas, a form of natural gas, in fact.
Yeah, okay, no, that's a good question. Yeah, okay, I'm familiar with what you're talking about now. Yeah, I don't think, I mean, that's not sustainable. But again, it comes back down to the key point I would want to make, which is water, food security, and energy are all interlinked. And if you say that the important issue of the day is energy, and you need to get more energy out, then water sustainability and food production is going to suffer. So in terms of if you're prioritising that, then yeah, you're gonna have a problem in terms of water resources. But as you quite rightly say, it causes instability as well in terms of the geology of the area, and it could create a lasting effect in terms of creating earthquakes and so on. So I don't really think it's certainly not a long-term solution. I think they might get a short-term gain out of being able to abstract some of the gases, but I don't think it's a particularly good idea. Hope that answers your question. In terms of creating water for places like Haiti and islands like that, I mean, I think it does depend on the area. I think in a situation like Haiti and some of the smaller islands, probably desalination is a good answer, possibly. Where there's no real alternative. But equally, there's lots of things like membrane technology that could be employed, but they are expensive as well. But again, in terms of the Singapore model, they could use a combination of microfiltration and UV. That would be perfectly acceptable.
Okay, has that answered your question?
Well, I've lived in that part of the world. I lived in that part of the world for quite a long time. was on one particular island where, in fact, we had the water supply for the local beer brewery was, in fact, desalinated seawater, and it was the best beer in the area, of course. So the expats drank that in preference to imported beer. But Haiti is so poor. I mean, it can't afford anything. So, I mean, it's a serious question. How do you resolve this issue? And, of course, it gets worse following all the natural disasters they've had.
Yeah.
To say you put in desalination, you put in all this sophisticated technology, there is no money for this.
Well, yeah, exactly. I mean, that's
so it's insoluble.
Yeah, well, exactly. I mean, the other thing is that people need to perhaps contribute to putting something a bit more robust in, or you come up with an innovative solution that actually is low tech, low cost, low maintenance. I mean, there's ways of. I mean, if you look at some of the areas in Asia where they've got metal problems, there are very, very cheap solutions in terms of actually removing the metal ions from water. And the local people can maintain them. There's no chemicals required, so there's no filtration replacement program. These things can be done at cost and very cheaply. But you know, each individual area needs to be looked at specifically, and it is very, very difficult to have one solution fits all. It's just not going to happen. So it has to be a combination of these things.
Okay, can we move on, please?
Jim Williamson from Imperial College. It seems to me that water supply and water treatment is based on a number of regional companies and privately owned companies. For sustainability, would it be better if we had a nationalised water system?
Oh, that's an interesting question for a Scotsman. In Scotland, in Scotland it's a publicly owned, unified organisation, compared to in England and Wales, where it is a range of privatised companies. I think there's about 24 in the UK at the moment, roughly. I mean, there are pros and cons. There are pros and cons for both, to be honest. I think in terms of the ownership model of the water organisations, that tends to have less of an impact on the performance of the company. What tends to be more significant is how these companies are regulated. I mean, it's certainly fair to say that in the UK is the only country in the world that's fully privatised. Chile, I think, is the only other company that comes close to full privatisation. Most other companies are a combination of public-private finance and publicly owned organisations. But you tend to find that good regulation actually drives performance more than the actual ownership model itself. There's lots of empirical evidence around that.
Yeah, if I may, I come from the English water company background. I'm long enough in the tooth to have worked within the local authorities, within the water authorities, and within the private water industry. And to be perfectly honest, it doesn't actually matter who owns the organisation. What really matters, as Richard says, is does the regulation that's applied to the industry work? We have probably got the best water regulation model in Europe, if not in the world. And I'm quite happy to say, as a scientist in the water industry, we would not have made the progress that we've made in the last 20, 25 years without a very well-defined regulatory environment to work in.
Yeah, I would agree with that. I mean, I think, again, it comes back to the point I made in one of the slides, which states that really you have to have a kind of stable government. You have to have a reasonably mature regulatory setup. There's actually quite a lot of work done by David Parker and Sal looking at the impact of ownership and regulation on the performance of companies, and certainly they conclude in a lot of their work that it's the regulation that drives performance rather than privatisation as a rule. So.
We got another question?
Can I come back on another one? What can be done about Thames Water? 10, 15 years ago, a third of their supply was supposed to be lost before it reached the customers. And I don't believe things have improved in that time.
Well, that's a good. That's probably a question for Thames Water, to be honest.
Yeah.
I mean, that's a very specific regional thing. I mean, I can't really comment on Thames Water's plans to reduce leakage.
No, I think it's unfair to ask that question of Richard. We can't comment on another water company's performance or otherwise. The gentleman in the front.
Gerald Green, I'm retired. You mentioned the aspect of a rogue government or an unstable government being able to control things and ensure the proper development of the water situation. But there's an associated problem, which is even worse, is where two countries share the same water source. There's one scenario if the water source is a river or a lake, which is the frontier, and they share that water. But there's the other scenario, which is much worse, where if the water supply is taken mainly from a river, which flows from one country to another, and the one that's higher upstream takes too much out, and what can the other country that's lower down do about it?
Yeah, you're absolutely right. I mean that is a big problem. Yeah, I mean that's going to cause problems in terms of what resources for the countries, and that'll actually create more conflict, and it will create more tension. So that is a big problem. Yeah.
Lady on the end front.
Hello, I'm a medical anthropologist, Gretchen de Soriano, and I was very interested in the picture you showed of an individual dwelling. Has any progress been made about homeowners who might be interested in having some kind of water capture or easing the water burden by reclaiming more of our own grey water or rainwater, or doing sustainable crops or allotments or that sort of thing to take the water pressure off of the southeast?
Well, I think that it varies again. Going back to the point about the different water companies across England and Wales, it varies from company to company. I mean, a lot of the companies do actively try and encourage people to reuse or think about reusing, but there's no real regulation requiring them to actively use grey water. So again, if it's about intelligent regulation, if you put in the right regulations that influence behaviours, then people will more than likely start to put in solutions that can capture grey water and rainwater and so on, and use that. But there's not really a legal requirement for that, as far as I'm aware. Whereas in Australia, if you take the Australian example, or even in parts of America, there is actually quite a large proportion of grey water used successfully. So.
Thinking more of innovation rather than regulation, because I think there's quite a few people who would do something voluntarily if there were affordable solutions available, affordable and practical. Do you know anything like?
That's a good point. Yeah, I mean, I think that the market is open for somebody to come in and provide a good, cheap, innovative solution for capturing and reusing grey water. I mean, the picture that I showed you up there was actually taken from an Australian manufacturer of closed systems. So, I mean, there are manufacturers and there are companies out there that have developed systems for capturing grey water, but I'm not so sure that it's really at the forefront of people's minds in the UK at the moment. But I think as water resources become more and more pressured, then I think you will see innovative solutions coming up.
Great. Gentleman on the end.
Thank you, Richard. Steve Lancaster, Royal Society of Chemistry. If I could just take a slightly pessimistic view and ask the question, what do you think would happen as the global population rises to 9 billion and as climate change minimises rainfall in areas where it's needed, coupled with economic growth in developing nations resulting in more demand for water-intensive agriculture? Do you think the planet's ecosystems can survive these scenarios?
That's a very good question. I think they will change. They will change as a result of that. There's lots and lots of consequences to the question you pose. It's quite a large question. I mean, certainly as developing countries become more developed and as wealth increases, then people desire more goods, or in general. So I mean, if you take the current example of China, where people are becoming more wealthy, they see a status symbol well, pork is a status symbol, so they want to consume more pork, which requires more resource. The price of pork goes up, and that affects the price of pork over here possibly. But you will see that as other countries develop and they acquire or want to consume their own goods, then the cost to us will go up. So that has an implication. But clearly, as demand goes up, you might enter a period where you have over farming. Again, you kind of asset strip the land, which is clearly going to have a huge impact on the ecology, biodiversity. So yeah, it's going to have an impact. Yeah. So that's why people like Sir John Beddington are very, very keen to highlight the issue now before it's too late, before we go past the tipping point and we can't recover it. So I think if we apply sustainable methods now, then we've got more of a chance of actually not going down that route.
Okay, thanks. Gentleman in the fourth row.
Yes,
I'm
long retired. I'm long retired. Used to work for BP Chemicals. I know a bit about this because I worked in plastics, and plastic pipe is being used for water distribution and for stopping leaks, because you use a completely fused joints system that virtually can't leak. But really, leakage is not a waste of water, because the water goes into the aquifer if it leaks, doesn't it? So it's recoverable again. What is lost is the energy, and what is lost also is the capacity, distribution capacity in terms of pipes that exist. But you're not losing water through leakage in that sense. Well, that's the first part of the question. I'd like to ask about something else, because you mentioned desalination as being very energy intensive, and I believe it is. But then when you started talking about Singapore, you mentioned reverse osmosis as being a solution to their problems. Is reverse osmosis much less energy intensive than presumably the other methods that involve distillation of water?
Well, I think in terms of the two parts of the question, the first part in terms of leakage, I think that you do lose the water. I think the water is unrecoverable, and it doesn't necessarily go into back into the aquifers. It could go off in all different directions. But there's more significant consequences to leakage than just the loss of water in terms of sustainability. There's the chemicals you use to treat the water. There's the potential pollution effect from the chemicals entering the subsoil around the area where leaks are actually occurring. There's the energy in terms of the pumping costs. So you're just pumping water out of the pipe and into the ground. That's a huge cost. And there are a range of other costs which I probably haven't mentioned. So in terms of leakage is an issue. If you can resolve the leakage issue, you can secure supply, you can reduce power costs, you can reduce chemical consumption. So it is quite a significant issue, I think.
You can tackle that with plastic pipes. You can tackle that by using plastic pipes.
Well, I think a lot of the majority of the infrastructure renewal programs in the UK are based around the use of plastic pipes. It's usually medium or high density polyethylene pipes, and as you say, they're butt fuse welded, or they might be pressure jointed or whatever. I mean, there are some pretty good pipes these days where you can put them through any type of material, even contaminated land, where you've got plastic with a kind of sandwich of an aluminium layer, and they're quite robust, and the jointing mechanisms in these types of pipes are quite robust. So that all of these things help reduce leakage. I mean, it's not inconceivable when plastic pipe ages that you get a split in it, and it can burst. But you're right, they are quite robust, and they're built to withstand quite high pressures, so they're quite a good solution. But they are extensively used in the UK at the moment.
Yeah, absolutely. Yeah. The first question, I would like another bash, I think.
Thank you, Mr. Chair. It was not so much a question, more a bit of information. A lady over there, I think, asked about how we can husband water more effectively, perhaps in the UK. There are, I think, under the new building codes, many opportunities for local authorities to insist that developers put in water conservation measures. And indeed, I'm aware of a number of new developments going on where there are extensive grey water systems going in, and that can be embodied in legal documents, the local development frameworks, which many local authorities are now going through, which then inform developers of what criteria they have to meet for water, for energy, for waste, and so on. And of course, you don't need all these codes. You can do a lot yourself. You can put a water butt in on the end of your drain pipe, and then you've got water for the garden, and so on and so forth. But on a large scale, in blocks of flats and so on, there's a lot of grey water going in now.
That's very good to know. Thanks.
Thanks for that. Gentleman in the middle of the fourth row.
Mark Scudamore, I'm a member of the Royal Society of Chemistry. You were talking about low-tech solutions in developing countries, and I think a good example of that is the building of sand dams, and in conjunction with terracing in rural communities in Kenya at the moment. And this has been very successful, and it works in areas of where the topography is basically sandy, and there's a large amount of rainfall, but just for a short period during the year. And I think the reason it's successful is because the local community are doing it themselves. They're committed to it, but it only works in that sort of environment. And there are other countries, I think, where it would work, but are there other types of approaches like that in other countries that you're aware of?
Yeah, I mean, there's, again, very similar approaches to the ones you've described. But again, there's also, in terms of extraction of metals from, going back to Asia, they're using basically big iron plates and they're trickling water over the iron to remove the metals. So there's lots and lots of low-tech solutions out there. I mean, slightly different, again, it's more to do with rainwater harvesting, but in places like Bermuda, where there's actually no natural water source, the way they design the roofs, they're all kind of square, and so square and terraced, so that the water actually trickles off the roofs and then is captured in storage tanks, usually in each of the different properties. Although Bermuda has actually installed a desalination plant up in Hamilton not that long ago, but up until that point they were using these fairly good sustainable methods. So there's lots of good examples of where at a local level they're actually using innovative ideas that don't cost a lot of money. It's just redesigning what they do. And I think we need to look to some of these good examples.
Two ladies in the middle row there, and squabble over the mic.
Hello, my name's Sue Gooders. I'm not affiliated to anything. You mentioned how rich in water you were in Scotland. So what are your water issues specifically in Scotland?
And well, that's a good question. We do actually have water issues in Scotland, believe it or not, even with the amount of rainfall that we sometimes have. I mean, last year, as an example, there were some areas in Scotland that were close to having a drought, but that's down to the way the infrastructure is designed. So on the west coast, the reservoirs tend to be shallower because we have a higher rainfall, so they recharge very, very quickly once they drop down. So as soon as you stop getting rain, which is the norm, then they don't recharge as quickly, and then you suddenly find yourself in a water stress situation. Whereas in the east coast, because we tend to have less rain in the east coast, the reservoirs are built a lot bigger, so they take a lot longer to drop down, and then they fill up at a slightly longer rate. So what we found last summer was in some areas of the west coast we were starting to get a little bit water stressed, whereas in the east coast everything was fine. And then you have to start to think about tankering water around, and that then becomes unsustainable because of fuel costs, transportation, carbon emissions and things. So that's not a solution. So there are some issues that we need to think about.
Hello, I'm Martina Di Fonso from the Parliamentary Office of Science and Technology. I had a question. I was wondering, is it possible to make the global water supply more sustainable by using the virtual water trade more tactically?
I think the simple answer to that is yes. I think the first thing is to be aware of it, and then, yeah, absolutely, use it a lot more tactically. We need to be very conscious of the water flow between countries as part of global trade, absolutely.
Yeah, couldn't agree more. That, to me, has got to be the way forward. We're just simply relying on other people's water.
Yeah.
It's as simple as that.
Yeah. We have to be very mindful of that, I think.
Gentleman on the end over there.
Jim Williamson again. Like most people, I just pay a monthly sum to Thames Water for the water that I use. And I've actually no idea how much water a dishwasher uses or 2 showers a day and the like. Would it help people to be more responsible in their use of water if they had visible meters of some sort?
Yes, absolutely, yeah. I think we both agree on that, yeah. That can only help. I think as soon as you start to give people information about how much they're using, then they start to monitor and measure it and be a bit more mindful of what they're actually doing. So yes, I agree with that.
Yeah, I think that if you look at the way that the electricity and gas industry has moved with domestic monitors, so you can actually see what you're doing, what you're using, how much your television uses when you leave it on standby overnight. And the very thought or idea of having visible water meters has got to help.
Yeah.
Must do. It's just the cost of installing them.
Yeah.
We've got about 5 minutes left, so any more with people with burning issues that they'd like to get ahead? That's killed it stone dead, isn't it? Gentleman in the middle there.
I don't think you answered the part about desalination, reverse osmosis.
In terms of the cost of energy, yeah. Sorry, I apologise about that. I think in terms of reverse osmosis and microfiltration, it's still very energy intensive, but it's less so than desalination. So again, it's all about identifying the right solution for the right situation. Really, it's all relative to one another. It varies from system to system. I couldn't estimate the difference in efficiency without knowing the exact treatment system that they had in, really.
Talking about...
so could you say who you are?
Adrian Williams, retired RSC member.
Thank you.
Talking about desalination, isn't it time to think about using waste heat from all sorts of power stations to do this? Usually now they're big units and they're in low-density population areas. A bit gets used for hothouses for food, vegetation and such like. But why is nobody building a desalination plant next to a power station, even if it doesn't run all day or all year? That there must be a lot of potential there for coal-fired power stations or nuclear power stations, which only run at about 30 to 40% thermal efficiency, and energy is being used to keep heat recirculating. Why isn't it being done? Any ideas?
Well, that's a good question. I think it comes back to the point I made a few times during the lecture. You have to think about water, you have to think about energy, food production, all of them together. And you're absolutely right. Until people start to join up these ideas, then it's going to become quite difficult. So I think you're absolutely right. People need to start thinking holistically about the output of one thing, possibly energy production, and how that can be applied to desalination or water purification or whatever.
Yeah. One last question, if we may. Gentleman with the jacket there. Oh, it's not in front of you. In front of you. Thank you.
Vivek Davda, PhD student, University of Birmingham. I was just thinking about the way the carbon tax works and maybe introducing the same system maybe for water, and to give people the financial incentive to do something about it and change behavior and their approach to using water and the way they manage their waste, basically. Because I've noticed in recent years people are racing towards carbon neutral technologies and ways of managing their waste and their output. Maybe we should do the same for water. What do you think?
Yeah, I totally agree. Yeah, absolutely.
One word answer.
Yes, yeah, exactly. I think we both agree on that.
Yeah, absolutely, yes. Right, well, time is pressing on, so I'd like to wind the questions up here and say a very big thank you to all of you for the questions and the debate. Really worthwhile. So if you give yourselves a round of applause, please. And final round of applause for Richard.
Thank you.
Thank you, Richard.
Thank you. Thanks.
Could I just say before you leave, thank you, Richard, and thank you, Dave, for coping with the lecture very well tonight under the circumstances, and it's been a very enjoyable evening. Thank you, too, for all being very patient. You've got one last bit of patience, I'm afraid. We have to escort you to the gate again, so members of staff are going to be down at the door, and we'll take groups of you. All the party guests are arriving now, so I think we need to keep everybody separate from the people arriving at the Royal Academy. So I'm sorry about that. No sneaking off. Thank you very much for your patience, and look forward to seeing you again.